Welcome to this video tutorial on the law of sines and the law of cosines. So first we are going to solve the problem you see in front of us, and then secondly we will look at another problem as well. Perhaps you want to try them before following along. In this case what we do is we find an angle. When we have an angle and a number directly across from each other, that's when we can use the law of sines. When those two things are across from each other, we use the law of sines. Now remember what the law of sines says. It says the sine of an angle divided by the side across from it is equal to the sine of another angle, which we'll call B, divided by the side across from it, which is also equal to the sine of the third angle divided by the side across from it. In this scenario, we have the sine of 18 and the side across from it being 61. Then we will pair it up with another side angle combination where we have a number. So notice here with the x and the 94 we actually have a number. So we'll say it's equal to the sine of x divided by 94. Now when we go to solve this, we will multiply both sides by 94. And we're going to go to our calculator and we type 94 times the sine of 18, make sure to close our parentheses, and divide it by 61. And that number is going to be what the sine of x is equal to, 0.477 approximately. So then if we want to solve for x, x is just going to be the sine minus 1 of that value, 0.477, because remember the inverse sine gives us the angle when we calculate it. So now we'll go to our calculator, and what we're going to do is take the inverse sine of the previous answer. Please make sure that you keep all of the decimal digits. We get 28.44 degrees. Now here's the thing, that angle x does not look acute. So the law of sines, you always have to be mindful of the fact that it doesn't know whether to give you the acute or the obtuse answer. So you will always have that ambiguity. And what we will do is type and find what we get when we take 180 minus that previous answer. And it's going to be 151.56. In this case, the picture is drawn to scale as far as whether it's acute or obtuse. So we will take the obtuse option for x. X is 151.56 degrees. Now once we have done that, we now have that x is 151.56, and we can then solve for w. So w, it's the third angle in a triangle, would be 180 minus 18 minus 151.56. So when we calculate that, we take 180 minus 18 minus that previous answer, and we're getting 10.44 degrees. It's nice to put that label on W. It is an angle measure, so it would be in a number of degrees. And then thirdly, what we're going to do is we can calculate Y then. So I like to start with the one where we had the numbers. I will use the sine of 18 divided by 61 is equal to, now when we pair up for W, W pairs up with Y, it'll be the sine of 10.44 divided by Y. Here we could cross multiply, so Y times the sine of 18 is equal to 61 times the sine of 10.44, and then we could divide both sides by the sine of 18. Watch parentheses as you type it in the calculator. So we want 61 times the sine of that previous answer divided by the sine So we want 61 times the sine of that previous answer divided by the sine of 18. And y is going to be about 35.76. Please keep as many decimals as possible, and if you store it as variables, that's even wiser as you go. Then the last thing we discussed was how to find the area of the triangle really easily. What you can do is you can take the one side, a side right next to it, and use the sine of the angle. So we could take 61 and 94 and the sine of w. Remember, the area is equal to 1/2 times those two things multiplied together times the sine of that angle, which was w, which was 10.44. So now when we go into our calculator, we take 1/2 times 61 times 94 times the sine of 10.44. Now, it would be ideal if you saved that full decimal so that you're not rounding, but I'm going to round, and 519.52. That would be the area of our triangle. One more problem we will investigate. Here it is. Now, if you look, we do not have any side and angle across from it combinations. When that's the case, you have to use the law of cosines. For the law of cosines, you have to focus on an angle. Let's look at y. It pairs up with 87. That would have to be our c in the law of cosines. Remember, the law of cosines is c squared is equal to a squared plus b squared minus 2ab times the cosine of c. In this case, c is the side length, and then the a and the b are interchangeable. It's the other two side lengths. Doesn't matter which one you put as a and which one you put as b. But then we will put the cosine of y as our number there. Now when we evaluate this, we're going to do 87 squared, which is 7569. Then we are going to combine 68 squared and 51 squared. Those are like terms, we can combine them. 68 squared plus 51 squared is 7225. But then this other stuff has the cosine of y attached to it, so it's not a like term. We just have to treat it separately. And it's going to be minus 6936 times the cosine of y. So now we subtract the 7225 from both sides. We're going to get 344 equals a negative 6936 cosine of y. And then we have to divide both sides by the negative 6936. Divide by negative 6936. And what we will have is that y is equal to, typing it on the calculator here, negative 0.049, negative 0.0495, blah, 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 blah. But that's not just y, so be careful on that. Sometimes people will make that error. That's the cosine of y. If we want y by itself, we have to take the inverse cosine of that answer. And when we go to our calculator, we take the inverse cosine of that previous answer, and it's going to be 92.84 degrees. Remember, the law of cosines always gives you the actual answer. You never have to wonder, is it going to be an obtuse or an acute angle? It's always legitimately correct. Now that we figured out that y is 92.84 degrees, we can use the law of sines. We can say the sine of 92.84 divided by 87 is equal to. Then we can take one of the other pairings. So we'll say the sine of x divided by 51. We'll multiply by 51 on both sides. So we want 51 times the sine of our previous answer divided by 87. And that's going to be what sine of x is equal to, 0.585 and then more. So 0.585 equals sine x. So x would be the inverse sine of 0.585. Now, it's ideal and recommended and necessary for you to keep all of those decimals. So we'll go to our calculator and we're going to type the inverse sine of the previous answer. And we get 35.84. Now in this case, we also have to wonder, could it be obtuse? But when we look back at the picture, x is clearly acute. So here I'm just going to write that it's an acute angle, and that's all we need. And then last but not least, we need to solve for the other variable, which will be z. But now at this point it's just a triangle. So z would be equal to 180 minus the 35.84 minus the 92.84. And when we do that, 180 minus that previous answer minus the 92.84. We get 51.32 degrees for z. But we're not quite done because there was one more thing that we did in class, which was determining the area of the triangle. So we'll take two of the sides that are right next to each other. I'll go with 51 and 87, and then the sine of z, which we just found. So if we wanted the area of this triangle, boop, the area would be equal to 1/2 times the 51 times the 87 times the sine of our angle z. It's a really quick way to calculate the area, and we'll take 1/2 times the 51 times the 87 times the sine of that z, which was our previous answer. And we're getting 1731.93. That would be the area. And those are how you can go through and do problems involving solving for the missing aspects of a triangle using the law of sines and the law of cosines. Basically, look to see if you've got a side and angle across from each other. If you do, go to the law of sines. If you don't, go to the law of cosines.